So our first speaker is Barry Burd, and he's going to be talking to us about teaching Haskell. Barry, take it away.
Here we are. Very good. Thank you. Thank you. Okay, let me just give you a little bit of background here. There it is. You can see my screen, yes? Doug, everything's cool?
Yep, everything's good.
Okay, all right. So I teach at Drew University across the river there in Madison, New Jersey. And I won't read all the bullets on the slide to you. You can read them. We have a small mathematics computer science department with just about 10 computer science majors graduating each year. I offered Haskell as a capstone course. It's not really capstone in the sense of a normal computer science curriculum. A capstone course is supposed to summarize everything that they know, or a lot of the things that people know in a particular curriculum, a sort of a grand finale to a college major. But Haskell isn't like that. It doesn't it doesn't use all the pieces from various courses that they've taken. But I wanted so much to teach Haskell that other people in the department said, yes, go ahead and do it. Use it as the capstone course. One of the things to remember is that the students in my course had very little in the way of functional programming background. We do Java normally in the course of the curriculum, but we don't even get to cover Java lambdas, or at least when we do get to cover them in our curriculum, students don't remember them. So they had very little in the way of functional programming. So I had to start from the ground up with that material. And here's a little bit of background on me. I have a PhD in mathematics and a master's in computer science that I got after the PhD in mathematics. The median program, the little program where you filter on both sides and then you combine the two results, that's what my first, wow, that's great in Haskell. I started by trying to approach learning functional programming by learning hybrid languages, but with hybrid languages, I wasn't forced to see the boundary between pure and impure code. I could do some impure code, I could do some pure code, and it didn't force me into that discipline of using only pure code. So I landed on Haskell and then started really getting into it. It turned out that learning Haskell for me was a labor of love, but I have to say that my understanding of it right now is maybe, I don't know, I'm gonna be modest and say 40%. I'm in love with the language. I want to do more of it. I taught it in order to learn it. That doesn't mean that I'm an expert. I kind of feel like an imposter giving a talk at this conference, but hey, I love doing it. My first point about learning and teaching is that each programming language comes with its own teaching style. I don't know if any of you are familiar with the Ada programming language. When that was introduced in the 80s, everybody who taught it had to use every bit of terminology that was part of the language. It was like a dictionary teaching Ada, and everybody who taught it did that. When people teach Java, there's also a teaching style that accompanies that. There are actually two teaching styles. There's, do we start by blasting the students with the notion of an object, or do we wait and teach objects and classes later? With Haskell, it seems as if the normal teaching style is correctness. And with the word dry there, of course, I don't mean dry as in the sense of tedious. I mean dry as in the sense of don't repeat yourself. So whenever I read work on Haskell, my feeling is that each sentence is as concise as possible with most of the people who are explaining it, and that every sentence is correct in the explanation, every sentence is economical, every concept is described once and only once and correctly. And that seems to be the typical teaching style with Haskell. I'd like to urge everyone who is explaining Haskell to the rest of the world to not do it that way, to instead be expansive, to explain every concept in 3 different ways before moving on, even if it means violating some slight technicality that involves correctness. When I taught the course, this was a 1-semester course for juniors and seniors, I got to teach only 3 topics. I got to emphasize recursion, recursion, recursion. I got to talk about types, mainly the data type, using the data keyword. And I got to introduce classes, and all of the rest of the topics in Haskell that I thought I would be able to cover in the semester, I could not, because students needed practice, practice, practice. That's my how do you get to Carnegie Hall bullet. How do you get there? You practice, practice, practice. So what I had to do to get my even better students to learn how to use functional programming and how to think purely functionally was to introduce a concept and then to have them work with many, many practice examples over many, many weeks in order to embed these things in their brains and make it be part of their muscle memory. It says in the bullet that there was no time for the usual introductory material, variations on lists, ranges, comprehensions. And in several cases in the language, there's more than one way to do the same kind of thing. There's if, then, else, there's guards, there's pattern matching. All 3 of those things more or less perform the same task. I had to stick to one of them in order to embed these things in their brains. I think I ended up doing a good job, and I think my students learned what they needed to learn, but they certainly didn't end up with a comprehensive view of the Haskell programming language. Did I insist on efficient code? Well, there were 3 possibilities. Yes, I did. No, I didn't. And there's a middle ground that I had to, I had 3 choices. Yes, insist on the best code possible. I did not have that luxury. No, let them write terribly dirty, inefficient code and see what happens. I corrected them if that happened. I think what I did when I ended up in teaching the course was get it in the middle ground, which meant get the complexion, the computational complexity right, and don't worry about squeezing every byte out of the code. So I didn't want them to create an n-cubed algorithm when an n algorithm would work. But on the other hand, if they wrote code that wasn't the best, wasn't the most efficient, could have been done better, I had to overlook it. So my mantra here, the thing that I want to ask everybody to do when you're explaining Haskell, not only to college students, yes, but even to your colleagues, to your peers, is take every concept that you explain and explain it in at least 3 ways. Every sentence that you say about the Haskell programming language, you should expand into 3 sentences with variations in the way that you describe it. I think in general, the pure functional world, the Haskell world, has a PR problem. We don't have enough books about Haskell. We don't have enough books explaining the kinds of the lovely concepts that are involved in the language. And I think in general, we're doing a poor job of selling it. When I tried to learn the language on my own, I found that none of the explanations were good for me. I tried very hard. I struggled. I have a PhD in mathematics, so I'm not a dummy as far as learning these things are concerned. But I found that most of the explanations were either too terse or too fluffy. So you've got this whole bevy of explanations about monads that use all the analogies, that compare it with a spaceship, compare it with a bottle, compare it with this and that. Those didn't work for me. But the terse explanations didn't, with the purely mathematical explanations didn't work either. I think what would help most in our world in order to make the rest of the world appreciate the beauty of pure functional programming is to be much more careful in the way that we explain these things. And it says there are more exercises. There just isn't enough way to practice the language. So just a little bit of background here. I've written several books on Java and Android programming. And my books aren't textbooks. They're just sort of standard trade books. I'm confession, they're in the For Dummies series. These books traditionally just are reference books. They have a little bit of teaching, a little bit of tutoring. As a result of my experience learning Haskell on my own over the last year, 2 years, on and off, I've decided that I must put exercises in my own books. I can't just explain things without giving people guides to try this, now try that, now give this exercise a try. We need more exercises. All the books that I decided to use for the Haskell course that I taught to college juniors and seniors, none of them had enough exercises. I scoured the web for exercises and couldn't find enough of them. So day after day, I had to make more. So I'm going to urge the community to do these two things. Explain everything that you explain very carefully and be redundant in your explanations, even when you're talking to your own peers. And let's see if the world, the functional programming community can create more and more exercises, a bevy, a collection of exercises that people can use to learn all sorts of aspects of functional programming. Yeah, we did attack monads. And there again, the way that I attacked them was not to explain them in the most concise way and not to explain them with analogies, but instead to take what would have been a 20-minute explanation and instead turn it into a 2-hour explanation, very carefully, questions and answers, not too mathematical, not too fanciful, and lots of practice. And when we did that, I think students picked it up. Students did understand what I was doing. I'm kind of proud of that part of the course. Just one note about the Haskell GHCI. I found it more useful than the REPLs in other languages. And there are two reasons for this. One of them is because it bypasses any issues in input and output, which is more complicated in the Haskell language than it is in other languages. In other languages, input and output is yet another function call. In Haskell, it comes with its own baggage because of side effects. So input and output in Haskell is much more difficult for a person who's being introduced to the language. I found that the REPL was really, really good in getting us around that. If I were teaching a Java course or a Python course and somebody said, well, you've got to use the REPL that's available for those languages, I would say, we don't need it. But for Haskell, you did. And of course, the REPL is good because in Haskell, single statements are independent of each other because of the purity of functions. So it's easier to just type one snippet of code and have it be meaningful. So the REPL is really good that way. In learning Haskell myself as a guide, I found two excellent resources. One of them is the page on monad challenges. If you're not familiar with it, you can find it by searching for monad challenges on the web. Students that I guided to that found it extremely useful. And there's a video by Brian Beckman called Don't Fear the Monad, where he has a very, very careful, well thought out conversation with the person behind the camera, where he goes over every aspect of monad and explains it in, I think, what is a very nice middle ground way. Again, not too technical, not too fluffy or fanciful, but gets the idea across about what a monad is and why it's useful. While I've got you in the room, I want to plug the fact that I do have an introductory functional programming video. Again, I have to say I'm a fake. I have an imposter syndrome here about this video, but I did an introduction to functional programming course for O'Reilly Media. It's a big 4-hour, 20-minute course in which I probably explain what you folks would could explain within 20 minutes, but went very slowly and very carefully. It's not Haskell specific, it's Haskell inspired, but it is programming language agnostic. And just to let you know that I've done that, that's, one of the things that I'm proud of. And now what I'd like to do, I realize that we're behind time because we started late. What I'd like to do is see if anybody has any responses. And my little notation at the top says question and answer. But what I'd really like to do is see, does anyone have any comments, any thoughts on this issue of how we make the rest of the world aware of this lovely and wonderful thing called pure functional programming?
So I think what we'll try to do here is you can say your question out loud to me, and I can repeat it to him in the computer, and we can maybe take a couple of questions that way. Let's see how.
And I want to emphasize,
Go ahead.
if it's not a question, instead it's an argument, then that's okay too.
Evie? One person agrees that Brian Beckman's video was fantastic for them.
Yeah, it was eye-opening for me. I have a background in mathematical logic, and I've gotten to the point where I can read and understand the discussion about category theory surrounding, but before that, it didn't work. I didn't see the motivation behind the theory.
Okay, we have another question here. The person agrees with you that exercises are very important and found Brian O'Sullivan's real-world Haskell exercises to be helpful as well.
Okay, let me make a comment about that. For the course, I looked at 3 different possibilities for books. One of them was Real World Haskell. Another was Learn You a Haskell. And the third was First Principles. And first, while I'm urging everyone to explain everything in 3 ways, I think First Principles would have been too wordy and too lengthy a text for my students. It is an enormous volume, and I don't think they would have had the patience to go through it. So I landed on Real World Haskell finally, but I think, if you've seen calculus textbooks, every section has, 60 or 70 exercises. I couldn't find that kind of thing anywhere, and I think learners need that for something that's as different from imperative programming as Haskell is. And while I like the Real World Haskell book, and I also noticed that there are some exercises accompanying Learn You a Haskell now, even combining the exercises in all 3 groups, that wasn't enough for my students. And in fact, honestly, it wasn't enough for me. I had to find even more practice to do. So I don't know, I have just a general question. Is anybody in attendance in a position to help create more exercises for the world of functional programming and to post them somewhere? It would be a lovely thing if we could have an enormous repository. There's a great 99 list, 99 problems, I think. And there's a Haskell version of it, but most of them are about recursion and not about other aspects of the Haskell language.
I just have to throw in one side note. I was actually going to ask you if you had seen the Monad challenges, which is something that I wrote, and then you had it in your slides already. So really, really happy to know that was useful for you.
That was
question here.
really great. Is it finished? Because when I looked at it several months ago, there were some gaps at the end.
No, it is not finished. But much help is solicited.
Thank you. Thank you for creating that.
My pleasure. Question here?
You mentioned on the slides of the epsilon delta, like it's like explaining epsilon delta things, and if you could say a few more words about what to elaborate on if it's not analogies, then like how do you make your explanation of them?
The question is about the epsilon delta analogy that you drew.
Yes.
And how can you tie that in a little bit more? Can you explain?
So epsilon deltas took me a year and a half, 2 years to, if you're familiar with calculus, it's the way of formalizing the notion of a limit. And when I took calculus, teacher would write the formal definition on the board and then go on, now let's do it. And it involves alternating quantifiers, which makes it difficult for students to comprehend. And so, you know, I was one of the, if I must say so myself, one of the better students in the course, and I didn't catch on. I didn't understand what was going on. So I didn't understand it until a year and a half later when I read a book that said, look, this stuff is difficult. We admit that it's difficult. We're going to spend a whole chapter elaborating on it. You see, what I find, and this is not specifically about epsilon deltas or about monads or about other ideas in Haskell or functional programming, what I find is that any sentence that you say or any sentence that you write can be misinterpreted by the person who's listening. Of course, that's not true about mathematical statements, but most people don't groove on mathematical statements. Most people need more intuitive explanations. So any intuitive explanation that you give is subject to misinterpretation, no matter how carefully you word it, which is why every sentence that I write in a book and every sentence that I say in a classroom, I try to say it in a few different ways so that people can asymptotically get closer to what it is that I'm trying to say in their understanding of it. And I think that's what's missing in the way that we relay Haskell and pure functional programming concepts to the world. I don't know if I've answered the person's question. Is that?
Well, I think we have time for one more question. Maybe we can connect you with the person afterwards if there's
Okay.
still questions there.
So you mentioned that you graded them on getting at least the computational complexity right for the exercises. I'm just wondering what resources you use for kind of teaching reasoning about the complexity of lazy functional programming.
Regarding the grading your students based on getting the right complexity right, what
Yeah.
resources did you use for teaching them how to analyze complexity, and especially complexity of pure functional programming or lazy functional programming?
I didn't use any. I was so busy teaching them just how to get the programs done. And when they had something that was awkward or crazy or the complexity wasn't right, I just on the spot had to say, no, it won't work this way, or it will work this way, but there's a much better way of doing it. I just by example, I didn't have the luxury and the time to use any particular resources or to emphasize that point as much as I would have liked.
Well, thank you very much, Barry. We appreciate this taking the time to be with us today.
And thank you very much. It's 6 in the morning. I just want to say it's 6 in the morning here in California. So it's, I'm awake and I'm going to stay awake for the rest of the day. Thank you so much for listening.
Thanks a lot.